Well, welcome everybody to our April 16th, 2026 meeting of the BCUG, Brookdale Computer Users Group, Computer Graphics Workshop. We've got some new faces and some faces we haven't seen before. Actually, a lot of these new faces aren't so new. We have Bill Cernak. Hi there, Bill. Haven't seen you in a long time. How you doing? Can't hear you. You're muted,
You're
Bill.
muted.
There he is.
There we are. I've been a little under the weather. I had a broken ankle, but I'm recovered now and here I am.
Okay, keep kicking. And then we have, Sandy Dumas is about to join us. Harvey Phillips. Hi there, Harv. Welcome back. My good neighbor, Joe Zuchik. Hello, Joe.
So, Bill, all those are cut in half on top of my monitor.
Say that again.
All of you guests are cut in half on top of my monitor.
I don't know why that would be. Check your settings for speaker, gallery, dynamic gallery, and play around. And hopefully you find the right one. You should be on gallery. Put your cursor in the upper right. Okay. And Faye Goldman. Hi, Faye. Where are you from, Faye? I don't know you.
Ardmore. I met Larry a couple of months ago, and this talk sounded interesting, so here I am.
Oh, well, welcome. A pleasure to have you. And Donna. Come back, Donna. Donna,
I am
where are
here,
you from?
Washington State. A long way away from you all.
How did you end up here?
I'm a member, believe it or not, of BCUG.
You
So
are.
been
I've
to a
been a
number of
member
meetings.
for over 3 decades.
Anyway, so I attend some of your meetings,
Okay,
not
welcome.
all.
Welcome.
Thank
And
you.
Sandy Dumas. There's our guest speaker, Larry Ward. Say hi, everybody, to everybody, Larry Ward, and
Hello.
everybody to Larry Ward. Dom,
Hello.
welcome, Dom. Ralph,
Yeah.
and John. So we're all together. One big happy family. Good turnout. Very good. Okay, I'm going to start screen sharing, and hopefully it's going to work so that we are all happy. Here's a question for John. John, if I go to advanced, over on the right, I have share options. I've checked share sound and optimize for video sharing. There's one other option I could check, share Zoom windows. Should that be checked? John, you are muted.
Unmute. Uh, I think you just want to share, Bill, unless you're sharing a video, and then you'd have to stop to reshare unless you just pick your whole desktop. So when you click on share, you're just going to pick desktop one. Don't bother going to advanced.
Well, I already have, and hopefully if I show a video, which I hope to do, it'll
Yeah.
work. Okay, let's see what happens. I am sharing. Can everybody see my
You
desk?
see your desktop.
Let's see. Oh, look at that. What a
Now
little
we see tulips.
good. Good. I
Beautiful.
want you to see tulips. I love tulips. Well, here we are officially set. Now there's some people here who we haven't seen before or haven't seen for a long time. As I mentioned, I've been a member of the computer graphics group since I turned 50, and I'm now 81. And one of the first things that I did when I joined the group 31 years ago was I signed up for the graphics workshop, which was run by Andrea Tarr. And Harvey Phillips was there. Hi there, Harvey. We're still together. So tonight, an introduction to our computer graphics workshop for people who are not familiar with it. I'd like to put together a little quick list for what we attempt to accomplish. So I'd like everybody just to write down one thing that you would put on that list that I could use as a promotional thing.
And put it
So
in the
just take a
chat.
moment and just write down one thing that you would hope to accomplish by coming to a computer graphics workshop meeting.
Put it in the chat.
Yeah.
No, I'm going to stop sharing, go back to gallery, and I'm going to ask everybody just donate one little idea that I could use. Again, this is for a promotional sort of thing that I'm trying to put together. At one time, we'd have 25 people at a meeting in person before the COVID virus decided to have its effect on us. John, as president, can you give us our first accomplishment idea?
I did. I posted it in the chat.
Okay, we'll just say it.
Oh, let me go up and read it. I come to the graphics meetings to socialize and to learn about and how to use graphics programs, including photo editing, video editing, AI.
Okay, that's good.
That's what I want to see.
Oh, Harvey Phillips?
You're asking me something?
Yeah, can you contribute one idea about why you come to these meetings of the Computer Graphics Workshop and have for 30 years?
Yeah, it was. I was very happy when it started because I'm very interested in photography and audio visual, and I just thought that this would be a great place to learn some things. And still learning after how many years? 30 years was.
Yeah, more than 30 years. Ralph Human.
Yeah, I put down using video and photography software, basically.
Okay. Bill Cernak.
Well, my main interest is to learn product names, which products are preferred, especially the free ones. And
We love free ones. We'll be talking about eventually Affinity. Dom.
I agree with what John said. Socialize, photography, and video.
All right. Faye, first time appearance.
This is my first time, so I wanted to learn something about the Raspberry Pi.
Yeah, I know nothing about Raspberry Pi, although it's one of my favorite pies. Joe Zuchik.
Did you just mention Affinity?
Yes.
I have a woman that's been my advisor in printing industry stuff for many years, and I've been using InDesign with a monthly fee, and she switched me over to recommended that I go to Affinity.
Yeah, if we have time, we're going to talk a little bit about it.
Yeah,
And
reading that. And that's free.
yeah, that's the word we like. Larry Ward.
Why do I come to these meetings?
Yes.
Well, this is like my fifth time coming to a meeting. This is the fourth time I'm giving a talk, and the other time was because I got you a speaker, so I was listening to her talk. So I come to these meetings to give talks.
Okay, Sandy Dumas. Sandy, you're muted. Not mutated, just muted.
I also for socializing and also about learning what tools are available, new software. And I especially was interested in this broad term of the raspberry.
You're getting cut off. I don't understand what you're saying.
She's interested in learning more about the Raspberry Pi.
Yeah.
Okay. Donna Armitage from Washington. Okay, Larry Ward is there again. There are certain reasons that are just basic, and I want to share them with you and see what you think. So hold on a minute as I go back to screen sharing. I put together a little something that I think states our aims.
You want to move the good.
Welcome all to the monthly meeting of the Brookdale Computer Graphics Club. Computer Graphics Club. Here you will see and hear Bill, Ralph, Dominic, and many others speak on different graphics topics.
Same shirt. Oh,
So do you think I covered the same points that you would have wanted me to cover? Anyway, Dom, thank you.
You're welcome.
Where did that come from?
Combination.
I created that, by the way. By the way, I just got that by email 6 minutes before the meeting started.
So Bill,
Yes.
Dom, put the name of the.
When are you going to introduce the speaker?
Oh, in a little while. Hang in. Okay. Let me get back to my screen sharing. Larry, I'm sure you want to get going, so I'm going to let you take over now.
Okay. Did you want to do an introduction? Usually you have
I
some
do.
material.
Okay.
Yeah, some material on me.
I got a lot of material on you.
Good.
Most of it's legal, so don't worry. Most of it. Can't guarantee everything, you know. Okay, screen sharing. Hold on. I got a member who's lost, I guess. Hey, Robert. Oh, Pam, we started the meeting. Join us.
Sujit joined, Pam joined.
Oh, you didn't get the Zoom link. Look, I sent it to you through groups.io, and that. John, hold on. I'm going to ask John to send it to you. We started the meeting already. Hold on. Oh, don't hold on. I'm hanging up.
Yeah, but which email address is Pam going to use?
I don't know. Whatever you have, send it to her.
She's got multiple email addresses.
Then we have a problem.
Well, you got to ask her on the phone.
I just hung up on her.
You'd be better off texting it to her, Bill.
Yeah, except I don't have her telephone number.
She just called you.
Yeah, that was on my regular phone.
You mean you can't text from that?
Can't do it. Can't do it.
Okay,
I'm skipping over a whole bunch of stuff that I will come back to. Larry Ward. Can everyone see my screen? April 16, 2026, Larry Ward, the Raspberry Pi as a platform for digital art. Now, Larry mentioned that he's done presentations for us in the past. Quick review. Larry, where were you on October 17th, 2019?
Here.
You were at the Eastern Branch of the Monmouth County Library in Shrewsbury, and you did a presentation for us all about fractals, what they are, their presence in nature, showed us some of your own fractal creations, and spoke about free fractal software, and I spoke a little bit about 3D fractal art.
Right.
A
So that
review
was
about fractals.
right. So that
That's
was a
what.
2 hour presentation, 64 slides. I've since updated it with another 5 slides with things that I wish I had told you, which would have only taken a few more minutes, but concepts. So it's up to 69 slides now.
All right. Well, maybe one day we will fit you in for an update if you care to. But for
Sure.
those of you who aren't familiar with fractals, here's one picture. A lot of complex mathematics is involved. We had time would review the concept, but we don't. Then on November 16th, 2023, Larry Ward, where were you?
I was in cyberspace with you, just like now.
Uh-huh. And your topic was AI and computer graphics, part 2. I won't go into part 1, but Larry was there for part 2. And you spoke about Bing Image Creator, and how do you use it? And
Right,
here's
which
an
is now
example.
called Image Creator from Microsoft. I'm assuming because they don't want to confuse the search terminology with the text to image generation technology.
Right.
This was
And
the
here's an
talk,
example.
right?
Here's
So
an
this was the
example of
first talk,
something done in Bing.
right? So this was the first talk I gave on the topic, and then I gave it at the Trenton Computer Festival. The third time we spoke was screening the talk that I gave at the Trenton Computer Festival, since I had learned new things in between the talk that I gave you and the talk that I gave at TCF. So we screened the talk, since it was recorded by the festival folks, and then there was a question and answer at the end session at the end.
Hmm. By
Yep.
the way, you never know where you're going to meet people who are interested in computer graphics and to join our workshop. Larry Ward, do you remember how we first met?
We were at a lecture at Princeton. I can't remember if it was Lisa Randall's astrophysics lecture. And
Sandy Duma was there.
yeah. So we had initially met at Princeton, and then we met again, and we didn't remember each other. But the second time you came up to me and you said, "Do you know anything about fractals?" And my head almost exploded, because I'm like, he walks up to the one person in the audience who's been studying this topic since the public was introduced to it in the August 1985 edition of Scientific American, in the computer recreations column. And I'm like, yeah, sure, I can give a talk on it. And so I started giving talks to you guys.
Yeah, well, what happened? I remember that night very well. My wife and I were going for a lecture on fractals, I think it was. And the lecture wasn't in the usual place where the Princeton public lectures are, and we were lost. And you looked like you knew your way around. So I said, "Hey, mister, you know where this lecture is? It's about fractals." And we started talking, and then we realized we knew each other from a previous lecture.
Yep.
And I got you.
Yep.
So, and then there's Ralph Human. Ralph, how did I get you involved with this?
We were a dance group together, right? We took dance lessons at the
Yes, we
Marlboro
took
Rec.
your wife and my wife and a few other couples were learning how to do ballroom dancing. And then there's Joe Zuchik. Zuchik, how did we meet?
Joe, I have no knowledge, have never worked with fractals. My background has been in photography, digital retouching.
That's right. And Joe is my neighbor.
I'm new to this subject.
Okay, so no matter where, there are people out there. Welcome, Sujit. Okay, I'm going back to screen sharing, a little bit more about Larry. What else do we have about Larry? Here's something that Larry sent, and I'm going to quote him. "I am a digital artist working in 3 distinct digital domains: software, generated art, much of which has a mathematical basis, image manipulation, and AI-generated imagery. The vast majority of my artwork, is of the first variety, namely software generated. I started creating my mathematical art in 2002 based on things I began learning in 1985. All of the code for my software generated art is written in C, C++, and or processing, whatever that means. I use my electrical engineering for my degrees, MIT undergraduate. By the way, who else do we know who went to MIT, John?
John.
Oh, yes, Sean did. That's right. Georgia Tech Master Software Engineering, Visual Arts, Graphic Design, all
And
sorts of
mathematics.
backgrounds, great products for myself, which can be appreciated from intellectual, visual, and functional perspectives. I have been part of the Manayunk Roxborough Art Center Visual Artists Co-op. That's a mouthful there. Since the start of 2019, a member of the American Color Print Society since March 2026, have permanent gallery space at Art on the Ridge in Roxborough, and have shown work in various galleries. My main art sites can be seen here. By the way, I'm going to have all this in the after meeting notes, so you can check out some of these links that are provided by Larry Ward himself. I have around 600 products across 25 product categories. Most but not all of my art is viewable online. And then I got this update yesterday in celebration of Tax Day and of my wife's birthday. Larry Ward wrote to me yesterday. Today, the two metal prints I submitted to the Bridges 2026 Conference's Mathematical Art Exhibit were both accepted. Congratulations, Larry.
Thanks.
It's a conference for people involved in the intersectionality of mathematics and various other aspects of society, art, culture, fashion, etc. Attending the conference has been on my to-do list for many years, well over a decade, at which point is too far back to recall. I didn't think of applying to the Mathematical Art Show until this year. Here's where my submission will be viewable when it is ready. Mark it on the calendar, folks. June 15th. Come back and check out this link. It is pleasant to be recognized by people who can understand the combination of your mathematics and your art at the international level. I may submit work to the fashion show in the future. All right, now for our guest presenter, Larry Ward. So I am going to turn off my screen sharing. And Larry Ward, as co-host, you're on.
Yeah, so I just wanted to say one thing. The language that you skipped over, processing, that was developed at the MIT Media Lab well after I graduated by two grad students there. And it's a language that's used to get artists to program and programmers to create art. And I'm reading that statement that you were going through that was particularly dense with text. I said I use my electrical engineering, software engineering, visual arts, graphic design, and mathematics background to create one thing, products for myself that have three things: a visual, functional, and intellectual aesthetic. So it's 513. And I'm up to over 600 products at this point. And I just keep making more, but I sort of lost track because it becomes kind of meaningless after 600.
Are all those products lumped together in one website, or are you going to have to go all over
You
the
go
place?
to the link tree and it has 5 of my storefronts there. There's one that's missing, Society 6, which had 70 of my over 80 shirt designs. And they don't make all over graphic tees anymore, and they got rid of most of their artists anyway. So the shirt that you see me wearing right now is one of those shirt designs.
And you also design mugs, right?
I
Coffee
designed
mugs and such?
a bunch of things, 25 different things, at least.
Okay, and you're going to tell us about some of them.
I'm focusing on the Raspberry Pi. That's the subject of this talk. Yeah.
Okay, take it away.
Okay.
You might want to mute the Raspberry Pi
The
Larry,
Raspberry Pi is okay, I'll do that, I guess. Hold on for a second.
I can mute it.
Yeah, do that, please.
I muted the Raspberry Pi.
I just turned off the monitor so you don't get the echo. So it's functionally the same. So anyway, this talk is on the Raspberry Pi as a digital art platform. And before I go to the next slide, I want to say, why am I giving this talk now? Like I told Bill, I think this is only the second time in my life that I've ever requested to give a talk. The first time was in a friend of mine's classroom at Princeton High School. She was a science teacher and she was complaining about some of her unmotivated students. And so, since I don't like to hear complaints, I said to her, would you like me to come and talk to those students? And she said, yes. So I got to talk to that classroom and engage them and talk to them about my background as an engineer. And I also got to talk to her, I guess it would be the equivalent of gifted and talented, or let's just say the college-bound, highly motivated students, at least academically. And what I realized, it was important to talk to both sets of kids for different reasons. So anyway, that was the first time I requested a talk. This time, I've requested this talk because I noticed that I had gained a significant amount of experience with the Raspberry Pi for my digital art, and I wanted to capture that experience and share it with you guys. By the way, I just admitted somebody. I'm not sure who that was, but I admitted them as a guest.
Good. Both of us did.
Okay. So anyway, that's why I'm giving the talk. So what is the Raspberry Pi? The Raspberry Pi is a single board computer that, and a single board computer is essentially a computer just like, just like your desktop machine, a general computing platform that has everything on it. Network ports, USB ports, the central processing unit, memory, the storage for programs, or at least the slot where you can plug in a little card. In this case, I have like a micro SD card. That's what the Raspberry Pi takes to store its operating system and any files that you put on it and any updates that you pull down from the network or copy onto it. So everything is contained in a little board. And let's see, I would have loved to, I'm not going to do it, but I would have loved to have opened up the Raspberry Pi on my desk. Maybe I'll do it at the end and actually show you the hardware so you can take a look inside it, the actual one running on my desktop, and how I have the various things connected up to it. Anyway, since it is a general computing platform and a lot of my art is digital, I got the idea that, hey, you know what? I could probably use the Raspberry Pi to do artwork, and specifically things that would not reproduce what I'm already doing by printing out art on materials like shirts or coffee mugs or posters or coasters or whatever, like I say, clothing, etc. Instead, use the platform for what it can do, which is actually, compute stuff. So one of the things or an art form that I could use that for is animations, both with sound or without sound. So that's what I started looking at. And I have lots of stuff running on my desktop machine that I've created over the past 24 years when I first started creating my mathematical art back in 2002. I've had stuff that I've either ported to Windows from Unix or created natively, which is most of my artwork, natively on Windows. So the thing is, I'm not going to drag my desktop machine into the gallery to hook up to a monitor and leave there. And I'm not going to spend, money like $1,000 or $1,200 for a dedicated laptop to show in the gallery. I don't use a laptop personally. So I said, well, let me check out this Raspberry Pi and see how much computing power it has. and it turns out it's wonderful. So anyway, by the way, let me back up for a second, because I jumped right into what the Raspberry Pi is instead of just continuing with the outline for the talk. So the outline for the talk is what I just did. What is the Raspberry Pi? My decision to use the Raspberry Pi as a digital art platform. Examples of my work on the Raspberry Pi. Platform capabilities that I've used so far on the device. Other things, capabilities that the platform has, and an idea for at least one future project for the Raspberry Pi. Okay. So I went into this. What is the Raspberry Pi? Single board computer. The one that I'm using for this particular talk and the one that I use in the gallery when I'm showing my work is the latest model. It's the Raspberry Pi 5 Model B. This one has 8 gigabytes of RAM when I bought it, but there's an updated version that has twice as much RAM. I don't even need 8 gigabytes of RAM. That's a lot for what I do. This model costs around, let's say, $100, certainly not more than 120. With the 8 gigs of RAM, the newest version with twice as much memory is, I think, $305 from what I remember. And there's no reason to spend that money if you don't need it. So this version, the Raspberry Pi 5, has more than twice the speed than the previous version, the Raspberry Pi 4. It's also the first time Raspberry Pi has made their own CPUs, as opposed to using Broadcom devices from Broadcom. So it's their first native silicon. This platform has 2 HDMI outputs, so I can actually power 2 4K displays running at 60 hertz. I only need one for my artwork. I'm not up to using 2 monitors yet. And it's got a bunch of USB ports, for keyboard, mouse, flash drives, like for either external storage or from when I'm transferring files. Since I'm not, using the network to transfer files from my desktop to the Raspberry Pi, they're on the same desktop with me here at home. So I just copy stuff off through the USB keys and go back and forth. So flash ports for flash drives. As far as the OS, the Raspberry Pi runs a variant of Debian called Raspberry Pi OS.
Hello, this is John.
It used to be called Raspbian, but now they switched the name to Raspberry Pi OS. And the great thing about it is that since it's a version of Linux, it's easy to update. So periodically, I will update all of the software on there with the package manager known as apt. It's a command that you use at the command line to add in, new functionality or to update existing functionality. Other package managers that you may have heard on Linux are, I think, DFN, Yum, and there's another popular one, but I can't remember what the name of it is. But there's essentially like 4 package managers. And like I say, it's software that comes with the OS to update the functionality. So that's some basic information about the hardware and the operating system on the platform. Oh, and by the way, this water bottle that I'm drinking out of, if I can get it such that it's not getting blurred out, that's another one of my products. So why would I use the Raspberry Pi as a digital art platform? Well, I sort of hinted at that or spoke about that a little bit already. It's because I can create art on the platform, display it in its native medium as it's, digital, instead of printing it out on physical media. So I can display both still images and animations with or without sound. I don't use the platform currently to display still images. I use it only for animations at this point. And like I said, I don't have to print stuff on physical media And therefore, since I don't do that, there aren't reoccurring expenses in terms of money or time, like having to go to the printer or having to whip out the credit card, log in, upload, whatever to whatever service that I'm using or vendor that I'm using to print something out, wait for it to come in the mail, and then
I have to I don't want to trouble you now, but I have to figure out how to do that. But I'm
okay. So I had to mute Robert there. I'm not sure what he was talking about, but I don't think it had to do with this presentation. So there's no need as well to meet the Thursday 6 p.m. deadline for hanging in the show that we open up on Sundays every month at the gallery that I'm a part of that Bill had mentioned at the Manioc Roxborough Art Center. I can just show up before everyone shows up at 1 p.m. and connect up the Raspberry Pi to power to the monitor and to the wireless mouse and the keyboard. And I use wireless in the gallery since we have wireless there. At home, I don't use my wireless for the Raspberry Pi, at least. I just connect it directly into the router because it's easy enough to do. And that way I don't have to have my personal home Wi-Fi password on an unsecured device, i.e. the Raspberry Pi. So as I mentioned before, the Raspberry Pi, depending on when you get it, it could be as low as $80 if it's not the current model, or it could be like, let's say, a little bit over $100 versus $1,000 or $1,200 laptop with enough oomph to run the type of code that I'm running to display for my artwork. So the thing is, if the Raspberry Pi walks out the door, I don't care because I've already run a script on it which removes all the code and just leaves the executables to run, the programs, the software to run and display the artwork. But you don't have my intellectual property, the actual code that I was writing. So I can turn my back on it and talk to other people and socialize. I can also leave it there for days on end. Since it's Linux running on a Raspberry Pi, it's reliable, unlike Microsoft Windows on a laptop. Two problems there. Windows is not reliable to run for weeks. And also a laptop shouldn't be running for weeks because you're gonna, destroy or wear down that piece of equipment. Whereas that's not the case for the Raspberry Pi. As long as in this box here, as long as the fan is running to circulate the air, and I'm with this particular fan, it's like a low power fan, let's say. For the code that I write, it's not so computationally intensive that I have to go to an active cooling system, which is a more heavy duty fan connected with a heat sink on the CPU for the device to dissipate so much heat because it's doing so many calculations per second. I haven't gotten up into that yet, but I'll talk about that a little bit later on in the talk. So anyway, this can run for weeks. I've let it run, I think, for as most as 8 or 10 days in the gallery unattended. And I come back, the code is still up and running. So anyway, a little bit about my development process. The same 4K display that I'm giving this talk on is the same 4K display model that I spec'd for the gallery because we didn't have one. So the great thing is when I'm writing code at home, I can see exactly how my artwork will look in the gallery because it's the same monitor model, except the acoustics are way better in the gallery than at home. It's like amazing how better the sound quality is here because in this room where I am, there's carpeting and a whole bunch of stuff that's going to dampen the sound, whereas in the gallery, it's a bigger open space. And so things are much more resonant and sound carries farther. And it's just a better experience overall. And by the way, I'm going to distribute this talk because I'm flipping back one page. As you'll notice, there are notes at the bottom so you can look for additional information. So about half these pages contain URLs for you to look for more information about the topic that I'm discussing. Okay. So now I'm going to talk about some examples of my art. I started coding and porting apps onto the Pi in the what would this be, like a year and a half ago, I guess, fall of 2024. And these apps are written in C++, and they're using the GIMP toolkit, the same toolkit, version 4 of this, the same toolkit that's used for the GNU image manipulation program. It was split off as a separate widget toolkit for you to write applications for. And the reason why I started using this is because at first what I wanted to do is write in PyQt, so the Python interface to the Qt graphics library. So that way I can develop on my desktop and just pull the code over, not even having to recompile it, and just run it. Actually, well, yeah, I would have to recompile it, but whatever. It seemed like it was going to be more portable, like I can run the same code on the Windows desktop that I can run on the Pi, but it turned out it's just way too slow. So it was easy to learn, and I was like, well, I have to write native code. What do people use? And I found GTK4, and it was very quick to come up to speed with writing in GTK4, especially if you have a background like mine where you're writing lots of graphical user interface stuff. And I have a lot of experience writing to Windows applications to the Windows GDK, the graphics device kit. So the Windows API that allows you to write code in Windows natively. So now what I'm going to do is I have 3 animations that I have written that I displayed in the gallery. So I'm going to turn on the monitor for the Raspberry Pi, and I'm going to stop sharing, and I'm going to, hold on, I'm going to mute the Raspberry Pi desktop. Let's see if I can do this. First of all, let me turn down the
Just start sharing from the Raspberry Pi.
Okay. Okay, I have that on. And I don't see the hold on, let me see something. I don't see the Zoom window that I had up where I can share, but do you see me in the meeting?
No, I still see the original share. So you have to go to the Raspberry Pi and Alt Tab.
Okay.
Can you Alt Tab on the Raspberry Pi to switch to another window?
Okay, yeah, I see it. Alt Tab. Okay, there we go. Got it. Okay, so let me grab the screen share here.
And it just switched you over. So now you're sharing, you're starting to share, and now we see the Raspberry Pi desktop. We still see the Zoom window.
Yeah, I have to minimize that.
And then you'll be able to find it again by Alt Tab.
Okay, and now I should see a way to mute.
The Raspberry Pi is muted.
Okay. So why am I getting, can you hear me in an echo?
I hear you, no echo.
Okay. Got it. All right, so let me just do something here.
So we see a pattern moving around, blue and red and green.
Okay. You know what I had to do? All I needed to do to stop the echo was turn down the volume to 0% on the Raspberry Pi, the monitor that it's connected to. So what we have here is a simulation of the Belousov-Zhabotinsky reaction. It is the first and most well studied and characterized of the three known chemical oscillators. So you mix a bunch of chemicals together. There's four of them: sulfuric acid, malonic acid, ferrium something, and some type of bromate. I can't remember. And what it does is it creates this reaction where the reactants form into products. They disassociate back into the original reactants, and they keep doing this as long as you're providing heat into the system. So the system never stabilizes. It's called a BZ reaction because it's named after Belousov and Zhabotinsky. Belousov was looking for a non-carbon based, i.e. inorganic analog to cellular respiration. So I'm assuming you guys ate dinner before this talk. Your body digests the food and now it wants to take advantage of it by extracting energy. That's respiration. So Belousov mixed a bunch of chemicals together, got this weird reaction, couldn't explain what it was, tried to get it published in the prestigious Russian journals, and they said, no, you can't, you don't know what you have here. We're not publishing your work. He eventually did publish it in less prestigious journals, but he was talking to a professor friend of his, and the professor friend had a grad student named Zhabotinsky, and he told Zhabotinsky, hey, go talk to Belousov and figure out what this reaction is. So Zhabotinsky figured out all of the steps to the reaction, and it's actually a family of reactions because you can replace one or two of the components. Anyway, Zhabotinsky figured out exactly what was going on in terms of steps to this chemical process. And so they both bear credit in the name of the reaction, BZ. So what I'm doing here is I'm using a particular mathematical object. I'm running a bunch of a system of equations on it that have parameters that I can adjust to get different types of visual behavior. But this one closely matches what you would see if you were looking at this reaction in a petri dish. You'd get these circular wave patterns that start from a clear solution. And then all of a sudden, you'd form these wave fronts. And as the wave fronts abut each other, it just goes into this continuous cycle. So this is oscillating both in space and in time. And like I say, it's the most well-known of actually three different reactions that we know of today that exhibit similar behavior. And I'm just going to try to pull up a web page here. I'm going to stop this.
And yeah.
Let me switch.
Are you able to show us the equation? That's
yeah, I'm going to pull up a web page, and I want to stop this so I can hit the space bar. I can do a bunch of things with this simulation. I can
and this is running, and we're looking at the Raspberry Pi's output.
Yeah, the Raspberry Pi's output. And what you're looking at, the color is a color map where I am generating the red, green, and blue components of the 10 or 16 colors in this simulation. And I called it the vomit color map because I didn't know what to call it. So I'm like, it looks kind of like vomit, so I'm calling it the vomit color map. I could have called it the RGB color map or whatever, or John's color map or Sandy's color map, but I just call it the vomit color map. So anyway, what the colors represent are the spatial concentration. So at each point, how much of a particular component of the reaction is at that point. And in this case, it's the reagent. A reagent is related to a catalyst, whereas a catalyst lowers the energy that it takes for a reaction to take place. A reagent accelerates a reaction. So either slows it down or speeds it up. And in this case, the reagent in the solution, which has a particular color, is speeding up. So if you were looking at this in the solution, you'd see the colors in the reagent, and it's speeding up the reaction. So that's what this simulation actually is. It is a mathematical model using a mathematical object to simulate a well-known chemical reaction that you learn in like chemistry class in high school or college, most likely high school. So let me just pull up a Wikipedia page in the Firefox browser on the platform. And by the way, the actual simulation is very smooth when you're looking at it on the display. I think it's because it's coming through Zoom, it appears to be a little bit jumpy. Where are my bookmarks? I have a whole bunch of bookmarks here. Let me just...
I'll just tell it to bring your pages back, right?
It's not the pages. I have bookmarks. So I'm just going to call up the browser again. And they should start appearing. Yeah, so here they are. Yeah, I didn't want to restore a session. There was no session to restore.
Mhm.
Yeah. So I think I just clicked on that link. Okay, here we go. So here's another simulation of it in this little window here. And if you were actually looking at it, like I say, in a Petri dish, where my cursor is, I don't know if you can see it, but it's the
No,
second.
we can't see it. Control
Okay.
plus plus plus.
Control, let's see, control. Where's the plus on here? Plus. Okay.
More.
Yeah, I'm just waiting for the zoom to catch up. It's pretty big on my screen. Okay, that should be good. Okay.
One more. Give it one more.
Give it one more? Okay.
Yeah.
All right. So you notice that Petri dish image down there, the second image?
Yeah.
So in reality, if you were looking at this reaction, it would have started as a clear fluid, or at least a clear color. It would have been either white or whatever the color is back there. I guess white, like clear. And then all of a sudden, you would start noticing these little circles appear, these waves of chemical reactions. And then they closely match, or at least the simulation, I should say, closely matches what you'd see in the Petri dish, which is these waves, like I say, of chemical reactions, wave fronts appearing and then just oscillating. If you were looking at this in a flask, you'd notice the flask turn from light to dark to light to dark at a fixed rate. And there's some versions of the reaction where it'll actually oscillate between 4 different colors, like red, green, blue, and purple. And what that is indicating is the dominance of a particular ion in the solution, like iron or cerium or whatever it is at that particular point in the reaction. So you can Google videos of BZ reaction, like 4-color BZ reaction, and you'll see that. In fact, I think I have a link up here, but I'm not going to bring it up. So anyway, I just wanted to show you what it would look like in a Petri dish or in an actual case. And let me see if I'm going to do this control minus minus so I can get back. And let me see if I can get to another bookmark. And here is a video. Okay. This might be the 4-color reaction. So I'll just play this. And at this point, while this is going on, I might as well mention, why do I do all this stuff? The reason why I do all this stuff is because I'm teaching myself a lot of different areas of mathematics. And since I don't have someone like a teacher to say, hey, you got it right, I take those mathematical ideas, whether it's physical modeling like this and simulation, and I turn those mathematical ideas into software, which then generates images, which your brain will interpret in as fast as 13 milliseconds. And you can output something to say, hey, I got it right. If the image doesn't come out as expected, either there's a bug in your understanding or a bug in the software itself. And you can go ahead and fix either one or both until you get it right. So sometimes the mistakes produce beautiful images. Like for instance, on this water bottle here, what I was actually going for was a hexagonal tessellation. And instead, what I wound up with is a tessellation of chevrons and diamonds. And I've done an Google search, image search for it, and I can't find it. I show it to my math friends, professors, and other people, and they hadn't seen it. So it was a pretty cool mistake to make to come up with a novel tessellation. So sometimes that happens. Mistakes can be, or misintentions. People say, don't call them mistakes. And I'm like, okay, it's a misintention. Sometimes those can produce beautiful results as well. But really, all this stuff started from me trying to prove to myself that I understood the mathematics of Mandelbrot's and Julius set fractals, from over 40 and a half years ago, reading about them till 24 years ago when I actually started writing code to produce the images and interactively explore the objects and look at relationships between the two different types of sets. After a while, what happened is I said, hey, I'm producing these images. I can make posters out of them. So I started making posters. And I was like, hey, I can start making coffee mugs out of these things. So I started making coffee mugs. And it just kept going from there. And people started asking for the products. And people started looking at it and said, hey, that's visual art. That's graphic design. And I'm like, what are you talking about? So it took me a while to realize what I was actually doing was creating artwork. Now I realize that, and now I actively will show my artwork in galleries or talk about it at conferences or places like this online. So that is how this resulted. It was just trying to understand mathematics and prove to myself that I actually taught myself correctly what the concepts are.
So Larry?
Yeah.
Larry, so right now, this is the browser and it's somebody else's video.
Yeah, somebody else's video. So you're seeing the you're seeing
back at the image that you showed us of your program running.
Yeah.
Did you develop the program on Windows and then move it over to the Raspberry Pi?
Yes. Initially, this was developed on Windows because that's what I started coding in back at my first job at Sarnoff back in 1994. So I had to learn Windows programming. So yeah, I started writing Windows code at home to like I say, show these mathematical ideas actually running.
What environment are you using? Are you using VS Code environment?
No, I'm not using VS Code. I'm using Visual Studio.
Visual Studio Code, the free version.
No, Visual Studio C++.
Yeah.
Yeah.
In Visual Studio,
yeah,
the program is called Code, and that's the free
version.
They're
two separate things. Visual Studio C++ is an IDE, an integrated development environment. So you can actually edit code. You can analyze the syntax. You can build the code into executable software that you can run. You can debug it. Visual Studio Code is pretty much an editor only. It's a lighter weight version of Visual Studio C, whatever. I have both installed, but I really don't use Visual Studio Code unless I'm using it as a remote editor across the network, like at a job. I don't use it for my own code development because it doesn't allow me to build and debug code.
So at least I know that Sujit DeMello, our member who's on here,
yeah,
also has a Raspberry Pi and is a code developer.
Yeah.
Using Visual Studio and things like that.
Yeah. And so to finish off your question, the original code was written for the Windows graphics device kit, the Windows GDK, and then it got ported. At least the mathematics routines, the algorithm stuff was ported directly onto the Pi. All of the stuff like the widget toolkits and access to the graphics environment and how you put pixels on screen, that had to be rewritten for GTK version 4 on the Raspberry Pi. Because it's a completely different graphics layer, obviously, between the two platforms.
So you can't just pick up the executable.
No, that's why I wanted to go with PyQt6, because I would have been able to just move the code over. But like I did that, but it was way too slow. Python is a interpreted language, and so it's just too slow on the Raspberry Pi for computationally intensive simulations, numerical simulations like this.
How big is the program that you wrote that displayed that thing that you showed us?
I'm going to go into my folder that you can see here. I'm going to go into the BZ folder, and I'm going to select the executable, and it says 66.4 kilobytes. Let me just bring up.
Not very big.
No, not big at all. The total size is actually 67,952 bytes.
Yeah, but it's only thousands. It's not gigabytes or
exactly.
anything.
Yeah.
So what is can you show us the Raspberry Pi desktop?
Yeah, I'm going to get rid of the browser. Okay. And here we go. I'm running it again. I can do things like stop it, advance it by one iteration. I can switch out color maps. So here's a red color map. I did basically all of the primary colors and all of the secondary colors. So there goes cyan, magenta, yellow.
Is this the Raspberry Pi desktop?
Yeah, this is the Raspberry Pi.
Is this the desktop?
Oh, the desktop itself. I see. No, it's not the desktop. Hold on. There's the desktop. Mine is blank. Normally what you would see is a background here.
It disappeared. I'm sorry, it disappeared.
It didn't disappear. You're looking at the desktop.
Oh, it's blank.
Yeah, that's the way I have my Raspberry Pi desktop.
Oh.
The only thing I have on it is a trash can.
And so do you have a terminal window that you're using?
I can go down here and I can click on the taskbar and open up a terminal window. There it goes.
And that's how you start the program running?
That's not how I start the program. This is only how I go into a particular directory and build a software. So I copy it onto the device. I have a file called a make file, which I think you know, John. I can go and type make, and the make file is the instructions on how to actually build the software so I can run it as an executable. So it takes the text code that I've written and then changes it into running code on the platform. And then I just launch it from the file explorer. So if we come in here, I'm going to click on the file explorer, and you can see the highlighted file right there is the executable. There's the software written in C. This is just a text file that I wrote before the meeting to remind myself of what keys are available to change things in the interface. There's the make file itself. And here's a parameters file that will tell me how large to draw the image on screen. So I don't have to recompile the code. It will just read the parameters from this file and also do a safety check inside the program so I don't make the window too small. So there's a minimum and I don't make it too large. There's a maximum. That's just good software programming, it's software development. But yeah, the parameters file will tell me stuff like that. I'm trying to think. Let me just open up this parameters file. Yeah, so it has the dimensions multiplied by 10 because each one of those effective little cells is actually 10 pixels wide. So it's almost the full size of the 4K display. And then the other numbers that you see there are the parameters for the simulation. there's three parameters that go into the system of equations, time varying equations that I put in here. And if I change any one of these, it'll change the look of the wavefronts or the pattern in general. So on these additional lines, I just have descriptive words for what the parameters would look like if I changed them to these things. So I have 6 examples there for myself if I wanted to show people different behavior of the simulation that doesn't conform to actual reality.
I may have derailed you from showing more of what you wanted, but I wanted to get at least some feel for what's going on the Raspberry Pi. The fact that it has a black desktop made me think that I wasn't seeing anything.
No,
And
the default desktop on the Raspberry Pi 5 right now is a fisherman in a boat in a heavily blue background. I just got rid of it and turned it off. I just say no background, just like I have on my Windows desktop.
so
It's
it's a Linux computer.
Yeah, it's having a background is just distracting, so I just get rid of it. And no, you didn't derail me. This is the whole point of these particular meetings. They're highly interactive, so you can ask questions like this.
I'd like to mention that I don't know how many other people notice it, but I look at Facebook every day. My wife posts her artwork on there in different groups. And one of the things that comes up for me, one of the kinds of things is tessellations, that Facebook decided that I was interested in tessellations, and there are some tessellations groups on Facebook and mathematical tessellations groups on Facebook, and they show up all the time. And another kind of thing is patterns that people have made into videos that you can get and use them somewhere, and they are displaying evolving things like your fractals and your video here. And those things show up in my Facebook feed all the time. So if anybody was interested in finding some more of these things and they're on Facebook, they could check out, search for tessellations, search for colorful videos.
How do you spell it?
Say it again, Joe.
How do you spell that word you saying?
Tessellation is Tessellation. Tessellation. 2 S's, 1 L. John, there's some sound playing right now for this rain simulation. Can you unmute the Raspberry Pi?
Well, let's see.
I think I can. Can I?
You did. You unmuted it, but you turned the volume down.
Okay. No, I still see it muted. I'm asking to unmute.
Right now. Oh, ask to unmute.
Yeah, I only turned down the sound on the monitor. I did not turn down the sound on the Raspberry Pi.
Oh, okay.
It's still at 100% volume.
Let's see. That one. I'm asking you to unmute. You have to go back to the Zoom, Alt-Tab back to the Zoom window.
Okay.
You didn't get to it yet.
Okay.
And you should be able to unmute yourself. Now, to unmute it, let's see.
So if this was actually playing sound, you would hear a sound file of recorded rain playing in the background. And I actually had this in the gallery on a rainy day. I specifically brought in this simulation, this rain simulation, because I knew what the weather was going to be like. So this was playing in the gallery and people were mesmerized by it. And by the way, every time I run this, it's different because these raindrops are being pseudo randomly generated. So every time I run the code, it's going to be something different because it's starting with a different numerical seed in the background for the random number generator.
Yeah.
This is completely dynamic. This is not recorded. It's being all these raindrops are being generated on the fly.
See, I can ask you to unmute, but you have to go to, somebody remember what the key shortcut is to unmute? Oh, if you press space, it will unmute. Press space on the Raspberry Pi keyboard and it will unmute it temporarily.
Okay. Can you hear it?
Yeah. I'm still not hearing it.
Okay, I can hear it in here.
Yeah.
Have you selected that option in Zoom to play the sound? You know, I believe there used to be a special option for that, right?
Well, we've got him muted. He's logged in two places.
No, in Zoom there is a setting to allow the sound to go into the meeting, the computer sound to go into the meeting.
Yeah. Well, if I can hear him speaking, I should be able to hear the other sound that's playing. Same as system, speaker, same as system.
John and Larry?
Is anybody hearing the sound of the raindrops?
No.
It may be my hearing.
No.
Let me just move my microphone closer to the monitor.
Are we going to be able to see any of Larry's artwork?
John, can you hear that?
I do not.
No sound here either.
Yeah, no sound here either.
None here either.
Nope, none.
Well, anyway, so Larry, you can continue.
Okay. Anyway, I have let me just put this back up. And I'm going to turn down the sound on the monitor because if I don't, I'm going to get an echo.
Now, if you
So anyway, let me just continue for a second. If you were able to hear that, you'd hear a sound file playing. I have not figured out how to programmatically get sound to work through GTK properly. I think it's a configuration issue that I'm having. So what I do instead is, instead of playing the sound file programmatically through the code I write, I just play it on what is that? The VLC player, and I just loop it.
Larry, can you hear me?
Yeah.
Can we see some of your artwork? That's what I'm interested in. I saw beautiful artwork.
I'm confused. You're looking.
Joe, I don't know whether you caught it before, but he posted a link. He showed a link, and Larry showed a link. But Larry, maybe you'll put the link in the chat of where to go to see your artwork.
Yeah, Bill is going to send it out, and I'm also going to send Bill. Yeah, and I'm also going to send Bill this presentation with links for the Raspberry Pi.
All right, thank you very much.
Yeah, you'll have tons of information to go through as with all my talks.
So
thank you. We appreciate it.
By the way, so Larry, if you just go back to the Windows machine and you start sharing, it'll switch you over to there the same way that by starting sharing on the Raspberry Pi switched your share over to there. So you can just go back and forth between the two machines.
Yeah, I know that, but I'm not going to do that right now. I'm going to show you a third animation.
Yeah.
It'll be the third and final one. Then I'll switch back to Windows.
Okay.
Okay, so now it's unfortunate that you won't be able to hear this sound, but you know what? I'm going to play the sound files. You know what? Let me try this and see if this works. If I play sound on my Windows machine, do you think you'd be able to hear it?
Same as we hear your voice, I think.
Yeah, so maybe this will work. Hold on for 1 second. Looking for the Raspberry Pi. Tell me if you hear this.
Let it snow in.
Did you hear that?
No.
Did you hear that?
No.
Oh,
That's so weird. Okay, I don't know what's going on. So what I'm doing is,
Larry, I had the same problem last month. What happens is when you start sharing, there's a thing that says share the audio with it. And if you don't do that, you'll have to stop sharing and start sharing again. And when you start sharing, you have to press the file that says share audio. I had the same problem last month.
okay,
Yeah, that's
so I'll
what
have
I
to
was trying to
figure
say earlier.
Yeah, I'll have to figure that out, how to do that on the Raspberry Pi. So what I was trying to do was something slightly different, which is just play a sound file out of my desktop
Yeah, but,
microphone into the microphone of the camera that you see me and hear me on.
but you're doing it through Zoom. And when you
Correct.
do it through Zoom, when you share, you have to share. When you share the Zoom, you have to click the thing that says share audio. If you don't
Right, but
click that, happened to me
he's
last
not
That's
month.
doing
not what
that.
I'm doing. You can hear my voice, correct?
Yeah, when
I'm
you're sharing a
producing sound
soundtrack.
out of my computer speaker, just like I'm producing sound out of my mouth. You should be able to hear it through the same mic. It has nothing to do with
All right,
permissions in Zoom.
all right.
Yeah.
Yeah, just as if my dog back here, wherever he is, starts barking, you should be able to hear him as well. That's all I'm saying. But for whatever reason, you can't hear it, so I'm not sure. But anyway, I'm going to move on to the third and final animation. So what this is, and some of you might have gotten my business cards. What you're looking at are these mathematical maps called Voronoi diagrams. And I'll just quickly explain what I'm doing. It's a section of you have a section of the plane, and it's Euclidean, so it's flat space, right angles are 90 degrees. I pick a bunch of random points in the space that are distinct. And from every single, and I'm going to assign unique colors to these points from the over 16.7 million colors a computer can represent. Then what I'm going to do is I'm going to pick a way of measuring distance between points in this space. It's called a metric. Most of you are familiar with straight line distance, like how you'd measure with a ruler, but there's infinite numbers of ways that you can measure distance between 2 points because it's completely arbitrary. So I'm implementing 3. The Manhattan metric or the taxi cab metric, like you drive from one point in New York to another in the city, is the sum of the vertical and horizontal distances between 2 points in the space. So if you take the x coordinates and look at the absolute difference and the y coordinates, the absolute difference, no negative numbers here, add those two numbers together, and that's the space between the distance between the 2 points. The third and final metric that I use, so Euclidean is straight line, Manhattan is like I just described. The final one is Chebyshev, which is the maximum of either the vertical distance or the horizontal distance between the points in the space. They produce different tile shapes. So what I'm doing here is I measure the distance from every single point in the image to each one of those points. And whichever point that I'm measuring to is closest to the point that I'm measuring from, I assign the point that I'm measuring from the color of the point that I'm measuring to. So if you take any one of these tiles, like let's say this purple one in the upper right that just disappeared, or this just look at any tile. All of the points of that tile are closest to the one of those randomly selected points of that particular color that I assigned at the beginning than any of the other randomly selected points. So I'm breaking up the plane based on minimum distance given a particular way of measuring distance in the space called a metric. And so what I'm doing here is every few seconds, I randomly select a bunch of points that I'm measuring to, randomly assign them distinct colors, randomly pick one of those 3 distance metrics, and I fade in and fade out over the course of a few seconds. And I hold for 5 when I've gotten to complete not transparency, what do you call it? Opaqueness. So I'm fading in and fading out these different patterns. And what this was representing for the particular month, it was a annual show that we have in December that memorializes one of the people who was part of the art center for a long time, who contributed a lot. So we have a memorial show for this guy every year. And what the theme was this year was the memory remains. So what I'm doing is these Voronoi diagrams are abstractly memories of yours that are coming to mind. You know, maybe it was like a brief memory of that you had on a vacation of yours, or you know, the birth of your first kid or whatever. These are abstract memories that come to mind, and then they fade out again after some time. So they come in, you consider them, and then they fade out again. And in the back, if you could hear it, I have a guitar riff that plays for about 18 seconds. It's very relaxing and very entrancing. So people are in the gallery, like just staring at this thing, you know, for long periods of time, because, like I say, it's entrancing when you're looking at it in the gallery and hearing this repetitive sound on an 18-second loop. I've used these Voronoi diagrams for a lot of things. I have them on my business cards. I have them on coffee mugs. I have them on, like I say, in this animation. I have them on gift wrap, et cetera, et cetera, et cetera. If you go to my main site, the first link in the link tree, the Math Art Store at Zazzle, when you get that info, you'll see these on tons of different products.
I put the spelling of Voronoi in the chat.
Yeah, capital Voronoi, after Georgy Voronoi, the Russian mathematician who studied this. These Russian mathematicians just keep popping out everywhere. You know, Belousov, Zhabotinsky, Voronoi, Chebyshev. They're all over the place. So anyway, this is the 3rd and final animation, and I wish you could hear the sound, because I say it's like a pretty cool guitar riff that I found, and it accompanies it. So
are these on your website of art?
No, these run dynamically. Remember, the 3 pieces of artwork that you saw are using the pseudo-random number generator in several ways to you know, several pieces of information that go into each one of the 3 pieces is continuously being remade. These pieces, they won't repeat in your lifetime. And in fact, for some like small size, you could have animations that won't repeat over the lifetime of the universe. That's how big the scale of numbers that I'm talking about. So no, they're not on the website. All of this stuff is being dynamically generated. I'm glad that you asked that, John, because I was emphasizing that point before.
So you could put a video clip of some of it.
I could put a video clip of this stuff, yes. So it would be a particular recording, a recording at a particular instance in time. But what you're seeing now is dynamically generated. It's not going to be reproduced ever again.
Cool.
Yeah.
John?
Yeah.
John?
Yeah.
I just got through doing a calibration on my monitor, and I had a perfect calibration at 120 brightness, and these things are phenomenal on my calibrated monitor.
They're
I don't know
beautiful.
what you guys have at home. It's incredible to see the way I'm seeing it.
Yeah. Oh, by the way, I just want to give a shout out to Richard joining us from Australia. Correct, Richard?
Yeah.
Yeah. He's muted, but yeah. I remember he comes in from Australia. So yeah, all my artwork that are these animations, they you'll never see the same images twice over the course of your lifetime because, like I say, I'm using the using the random number generator, so pseudo randomly grabbing variables either once at the beginning or multiple times over the course of the artwork. So, like I say, in here, each one of these images, you're randomly generating all of the points that you're measuring distance to, which is corresponds to the number of tiles that you see, which also has a direct effect on feature size, which means the more points you add in, the smaller the tiles become. And also, those colors are assigned pseudo randomly from all 16,777,216 colors a computer can represent. Obviously, your eyes only see 1 million because each color cone in your eye can only see 100 shades. So 100 times 100 times 100 is a million. Your eyes are not computers looking at bytes, which are 8 bits, 256 values each. Your eyes don't work that way, obviously. And I'm randomly, like I saying, selecting from 3 different distance metrics. They're the most popular metrics that mathematicians use: Euclidean, Manhattan, and Chebyshev.
Do you control the brightness?
Yeah, so what I'm doing is I pick a random set of points. I assign them random colors, so there's a certain number of distinct points, which each has a distinct color. I make sure that each one has its own color, and I randomly pick from one of the 3 ways of measuring distance. And what I do is every 300 milliseconds, I fade in the image from being completely transparent all the way to being completely opaque over, I think, 10 steps. I hold for 5 seconds, and then I fade back out every 300 milliseconds, or as fast as a Raspberry Pi can actually do it for an image this size, until it goes completely clear, and then I repeat the process.
At 120 $10 per millimeter square looks beautiful.
Sorry, I can't understand, Joe.
I said at 120 $10 per millimeter square, the color saturation looks perfect.
Okay, gotcha. Cool. Yeah, and it looks pretty beautiful on natively on the monitor that I'm looking at it on. My monitor, the 4K monitor, as well as the monitor that I'm borrowing from the gallery that I picked up last night that I got to go and return tomorrow.
And I just did a calibration. Beautiful.
Yeah. I mean, if you can see this in person, it's beautiful to see stuff on a 4K display. And it's pretty cool to think that this tiny little box, and you can look up the dimensions. Hold on for 1 second. I just need to grab a ruler.
He went into cyberspace, it looked like.
And here it comes back.
Yeah, so this box measures less than 4 inches in one direction. Then it measures about 2.5 in another dimension. And then it's about 1.25 deep. So it's a tiny little box that has the single board computer that has
It's
all
powered
of its
by
functionality.
Is it powered by a brick in the power cord?
Yeah, there's a it has its own particular power supply that comes with it that I connect into the power port that provides the correct current and voltage to power the thing.
So the point about the Raspberry Pi, if I just go back and summarize a little bit, is that it's a relatively inexpensive portable device for you to take somewhere that you can leave running for a while to run a program that you've developed elsewhere.
That is correct. And I'm using it as a digital art platform. So when I go into the gallery, I bring my wireless mouse, I bring my keyboard. I don't need to bring a network cable. I leave the HDMI cable there and the power cord, but the keyboard and the mouse I take home. And I start up my code, disconnect the keyboard and mouse, and then I could just walk away, go back home, go grab a cup of coffee, or talk to my fellow artists and visitors in the gallery.
Is it on Wi-Fi? Is the
Yeah, I
device?
said the gallery has Wi-Fi. We have I think a 5G network in the gallery. I don't know who our provider is. Let's just say it's Verizon. So I hook in the gallery, I hook to the wireless. At home, I'm not going to put a credential, my home passkey, whatever you call that, the wireless password, on the Raspberry Pi, because I have the Raspberry Pi auto log in. So I don't type in a login. It automatically will just bring up the desktop. So I
Yeah.
can start automatically launching my code. So I
But
don't
you
want to
could
have,
you could log into the Raspberry Pi remotely.
yes. Yeah, you can do that. There's actually a Raspberry Pi service that allows you to do that. But I'm not trying to get into all of that. I'm trying to focus in on my presentation so I can get it done. There's
Yeah.
tons of stuff that we could talk about the Raspberry Pi, because it's a general computing platform. But I want to stick with how I'm using it as a digital art platform.
Could you tell us, excuse me, if other people have questions, go ahead. I didn't understand what GTK4 actually is.
GTK4 is the fourth version of the GIMP toolkit, which is the graphics toolkit that was used to develop the GNU image manipulation program, the software that we use instead of using Adobe Photoshop, because it runs on Windows, Linux, and Mac OS, and it's free. So that
is that on GitHub? Where do you get it?
You just Google for it and you can find it. All this information is in the presentation, in the notes. You'll have access to it. Yeah, I mentioned earlier that I put all this information in the notes when I send you the slides. So anyway, I want to go back to my I want to go back to the desktop so I can finish out the presentation. Place current share, and okay, share. Okay, so now I'm done with my 3 examples, and we only have, well, that was half the slides, but we're going to go through quickly. So what capabilities have I used so far? You can see my screen?
Yeah. Your slides.
Okay, good. So capabilities on the device, on the platform so far. 1 HDMI output, like I said, it can put up to 2 4K outputs at 60 hertz. I'm only using 1 because my animations only run at 1 at this point. I don't have any ideas at this point for running using multiple monitors. I'm using the web browser, and as I showed you, I have bookmarks on the web browser. There's 2 that I have installed here, Firefox and Chrome. I can't remember if there are any others, but those are the 2 that I install on the Pi. Those are easily accessible. They're like readily available for you to install. And I use those, like I say, for explanatory material. So I can quickly pull up web pages on things like the Wikipedia page or something else for like Voronoi diagrams. So I can show people very quickly in the gallery. And then audio. So very simple stuff, but there's a whole bunch of other capabilities available for future use. So yes, I'm using the network connection to update the device and do this talk, wired and wireless, but I'm not using it in my code to pull down, like, for instance, information across the network or whatever, like I've done with other projects. I'm not currently doing that on the Pi, but when you have that network connection, that allows you access to anything on the web, anything on the internet that's reachable. So that's pretty, that can be pretty powerful, a pretty powerful capability if you actually are creative enough to figure out ways to use it. It has a whole bunch of general purpose inputs and output connectors for me to plug in sensors as inputs or outputs for lights, for regular motors that run at a constant angular velocity, or stepper motors, which I can turn at particular angles and particular speeds. That's going to come up later when I talk about a future project, potential future project. You can hook up cameras to this. And if you're going to hook up a camera, I suggest don't hook up an arbitrary camera. Buy one from Raspberry Pi that actually has been vetted and debugged with their libraries, their software libraries, which you can pull down. There are various types of cameras. And if you look at the bottom in the notes, I have a link to their products page, which you can go and you can see different types of cameras. So high resolution cameras, AI cameras that have chips on them that will perform things like segmenting images or recognize facial recognition or whatever. You can buy a whole bunch of fancy different types of camera modules for use with the Raspberry Pi. Multiprocessing. There are actually 4 separate computational cores on the central processing unit in there. I'm only using one for my code, or I should say I'm allowing the operating system to pick which one of the 4 cores runs my code. I'm not actually specifically doing multiprocessing where I'm assigning processes or threads, sub-processes to particular cores, because I'm not doing that much. I'm not doing the type of computation like when I was doing my fractals for my first talk that would require multiprocessing. And if I do that, the chip will run hotter, and then I'll have to buy an actual active cooler, which is, like I say, a bigger fan combined with a heat sink that physically connects with thermal paste onto the CPU, so you can get more air around it to dissipate that heat, because it's using more electricity to do more computations in a given amount of time. There's a real-time clock on here, and you can actually install a battery, so you can actually have a sense of the time of day, even when the Raspberry Pi is shut off and not having a network connection. Yeah, the Raspberry Pi uses a network protocol to pull the current time. So if I switched back to the Raspberry Pi desktop, you could see that it's running the correct time, but it's not using the native real-time clock functionality as I'm describing here. It's getting the time off the network, setting up whatever internally and displaying that time. As I said, it can power a second 4K display. It has Bluetooth capability. I have that currently turned off because there's no reason for it. The only time I would use Bluetooth is to connect the Raspberry Pi to my wireless headphones if I was doing something on the Pi that required me to do so, but I don't use that for my artwork. You can buy touch displays, other add-on boards called hats that provide additional functionality, like those sensors that I was talking about. And it's all sorts of different types of sensors. You can measure how much light is falling onto the device, the temperature, the humidity. There are magnetometers. There are accelerometers, a whole bunch of different types of add-on boards, and not just sensors, other things as well. And then there are peripherals that you can pick up as well. They're not sensor board or add-on boards, but they add other types of functionality. All that stuff is available at the link that you see down there, raspberrypi.com/products, that you can take a look at. Okay. So I've described to you functionality that I've used so far, additional functionality that the platform provides, and there's this sort of addendum that I'm talking about this. Let's see, I can't see my view of myself. Hold on for a second. I'm trying to find myself. Can you guys see this that I'm holding up?
Yes.
Okay. This is an enclosure for a solid state drive, and this is the cable that came with it. This is what I used when I asked you guys for assistance in cloning my SSD drive, my 256 gigabyte SSD drive to a 2 terabyte drive for the desktop that I'm giving this
Yes,
on.
yeah.
Inside this enclosure, and I'll press the button, there goes the SSD drive that came with my Dell desktop. This is just protecting the drive for now, but I can easily use this for a future project with the Raspberry Pi where I want to store data on here. So I'm backing up data off the device itself or retrieve data off of this. So let's say I have something where, maybe I pull down some information off the network daily, and then I retrieve it, using some code to do some type of dynamic behavior for my art project. Anyway, I can hook up an SSD drive to the Raspberry Pi. It wouldn't be using this particular cable, or it wouldn't terminate in this. It would have to terminate in a standard USB C connector to connect into the ports. But that's what I have this for. I keep it because I'm not going to toss it. It's still a good drive until I come up with a good use for it. Or when I come up with a good use for it, I should say. So anyway, I'm just bringing that up as an additional addendum to this talk about a future project. Which brings us to this. I have a Raspberry Pi 4 that I never used because I bought it. Can you see it?
Yeah.
Okay. I have the earlier model. I never used it. And then the Raspberry Pi 5 came out. And so I bought one of those. And so I've had this and I've never used it. I occasionally will bring it up, connect it to a monitor, and update the software. But what I want to do with this is in the Manayunk Roxborough Art Center courtyard, I want to come up with a weatherized outdoor permanently installed kinetic art piece. So I have, obviously, from my electrical engineering degrees, I have knowledge about the hardware and how to interface this to various devices for input and output. I can program it, obviously, but I don't have the mechanical skills for the enclosure and the electrical skills for like the electrician type skills. So this is going to be a collaborative art piece that I've been discussing with my fellow artists at the center. So I haven't come up with it yet, which is the exact thing that it's going to be, hence the big question mark. But I can imagine it looking at how much sunlight is out, the presence of people in the courtyard, the sounds of squirrels and birds, whatever, rainfall, and reacting by outputting sound, light, motion, whatever, like through a motor, whatever. It's going to be a collaborative piece. I'm not just going to have other artists facilitate my vision. I want to work with them and see what ideas that they have, and we can come and work together. Hence the big question mark, because I haven't figured it out. It's a long-term project, but it's going to be based on this particular hardware. And by the way, now that we're looking at it, you can see 2 sets of USB ports. The blue ones over here are USB 3. These are USB 2. There is an Ethernet connection here. Here are the 2 HDMI outputs. Here's the power connection.
Could I just mention for a moment to help with this? Folks, when you're looking at this, remember that you can go up to the top of your Zoom screen and go over to next to the star, to the right, record star, and then there's a place where you can pick the kind of display. And if you put side-by-side speaker, then you can grab between the 2 images and make them equal size so that you can see Larry more clearly. Like right now, I've got half the screen showing his slide, and right at the moment, I'm seeing Harvey in the other one because he made some noise and he turned into the speaker. So as soon as Larry starts talking again, he will show up in my right window and he will be big enough for me to see what he's showing if
Hey,
you
John.
aren't seeing him.
John, I just started talking again.
Yep, and now I see you.
So, what else do you have on here? Here is the micro SD card that I was talking about.
Yeah.
That goes into a slot directly on the bottom. There's a place to connect a camera, and I think potentially also an SSD drive. There's the heat sink that's dissipating heat from the central processing unit, CPU. Here's a row of pins for the general.
Hold it down a little bit lower.
Can you see
in front
that?
of your chest? Yeah.
Okay. Here are a set of pins that are the general purpose input outputs that I can connect either sensors or actuators to. So I can get input and also output stuff. And there's the bottom of the board. And you can see other stuff on here, but you can also go to the links, and particularly the one that I have on the bottom of this slide in the notes, and pull up information about the Raspberry Pi 4 Model B that I'm holding up right now. Okay. And now I'd like to conclude the talk by saying, go to raspberrypi.com for more information on hardware and software of these particular platforms, both the 4 that I just showed you and the 5, which I actually use in the gallery. And there's also a link to the GTK project, so you can see the widget toolkit that I'm writing my animations in. Oh, and I forgot to pull this out earlier. This is the fan that can be used for the Raspberry Pi 4. I'm leaving it in the plastic. It connects directly into this connector, via this connector into the Raspberry Pi 4. There's a place for it that you can connect the fan, and you put the fan on top of the heat sink, or above the heat sink, and it dissipates the heat. But you have to actually buy an enclosure for this. I didn't bother buying an enclosure for this one. And you can go and see the Raspberry Pi cases if you go to raspberrypi.com. And that concludes tonight's presentation. If you have any additional questions, feel free to ask.
Larry, where is this Pi produced?
Where's
What
the Pi
country?
produced? Well, Raspberry Pi was started by Eben and Lauren Upton, a husband and wife couple in England. They were hearkening back to the days, I think, of the BBC computer that you can program with, what was it, BASIC? And they wanted to have a computing platform that is open to tinkerers and hobbyists, like people like me. And so it's designed over there. Where they actually manufacture the chips and the hardware, I don't know, but that information is on the site, and it's probably on the Wikipedia page too.
Okay, and the Raspberry Pi, it's been around for what, 2 decades or so?
Something like that. I can't remember exactly when. I mean, like I said, this is the fifth version of the device. So.
Mm-hmm.
I have
Yeah.
a quick question.
Okay, Larry, you're going to make
Hold on,
this
hold on.
whole slide presentation available?
Yeah, hold on. Someone started talking just before you did, Bill.
Yeah, I have a quick question for Larry, if it's okay.
Yeah.
If one were to get a Raspberry Pi unit and it would write peripherals, what language would you need to know to construct a device that can control a slide projector and a digital camera?
That would depend on the particular hardware that you're using. The languages that I know of that are used on the platform are Python and C/C++.
Thank you.
But it's a general Linux platform. So any languages that run on Linux, will run to do whatever it is you need. You just have to pick one that's appropriate for whatever interface that's suggested for your peripheral.
This is the kind of thing that we sometimes talk about in the Linux workshop.
Yeah.
In fact, I mean, Sujit Is Sujit still here? No, Sujit seems to have left. But Sujit told us about a Raspberry Pi setup that he made to control the temperature and humidity in his cigar humidifier. Right? He has a cigar collection with a
Yep.
humidifier for storing them, and he has a Raspberry Pi that controls the temperature and humidity in that. Now, he's a programmer, but if there were people interested in pursuing some projects about Raspberry Pi in the club for some time, we could set up another meeting where people could share their experience about the use of the Raspberry Pi.
Yeah, and I'd be
Everybody could
happy to
learn.
attend that meeting.
Yeah. Well, as I say, we have been talking about them in the Linux meeting because it's a Linux-based system usually. You can run Windows on a Raspberry Pi, but again, as you said, it's not very powerful. So, but for some people, a Raspberry Pi would be able to do everything that they want to do because they'll do it through a browser.
Yeah, so I think of it like this in terms of hardware hierarchy. I think of Arduinos on the bottom, Raspberry Pis in the middle, and then something like a BeagleBone, if you're just like need an insane amount of hardware, like the computing power. So Raspberry Pis in the middle of those two extremes. I don't know if
Yeah.
everyone's familiar with the BeagleBone or some of the other like development kits, like you used to be able to hardware development kits that you could get from Intel or wherever. But I don't even deal with those. But the ones that I'm familiar with are Arduinos and Raspberry Pis and BeagleBones just a little bit.
With regard to Dom's question, Dom, I know that you check all kinds of do searching on the internet, but if you have a question, put it into the discussion forum and see if anybody else comes back with some answers, because they may have searched with just some different terms and gotten other answers. You know, I find that I get a lot of information out of Copilot. I just asked it about building a security system using a Raspberry Pi and a Wise Wi-Fi camera. And it said, oh, sure. It gave me all the instructions for how to do it.
Yeah, I also use
Copilot.
Copilot. It's great. It's a great as a super Google, as a friend describes it.
Yeah, well, even better than that. It digests it all and gives you a set of instructions. Thank you, Larry.
You're welcome. So, did you guys learn anything tonight?
Yes.
Good.
I didn't know what the Raspberry Pi actually looked like, and we got a taste of it. It's a lot to digest, but you were the man to do the presentation, and we thank you for your effort, Larry. Our time is going quickly. So, Larry, again, we all thank you. And stop sharing, and I'm going to wrap it up, okay?
Yep. And Bill, I actually prefer Blueberry Pie as opposed to Raspberry Pi, but that's a conversation for another night.
Okay.
Thank you very much.
You're welcome.
Thank you.
Thank you.
Yeah.
Oh, for those of you who did not get the notices of the meetings, such as Harvey and Joe Zuchik and Pam, please give your email address to John. And John, I hope you'll do what has to be done to add them to the
Well,
list.
I can tell you, you sent this out to the general group, not the graphics group. Everybody in the club received the email. It may have gone to spam. In the case of Pam, it may have gone to whatever email address she had in there, and she's had chronic problems finding things in the many email addresses she has. Harvey, I can check and see if yours bounced, but I am confident that everybody in the club is in groups.io and they all received this email. Whether they saw it or not is another question. But I'll point out that you can always log into groups.io, which is our forum, and go to either graphics or general, wherever Bill sent the thing from. And for any workshop information, you can see the email that was sent out because it's there in the messages. If you can't find it on your machine in your emails, you can still go on to groups.io and look in the messages there because it's still there.
Okay, John. Thank you. And if anybody's in screen sharing mode now, like I guess, John, are you?
No, nobody
No.
should be. You stop. There's nobody
Okay,
screen
I'm
sharing.
going to go to screen sharing and go back to my listing and see what I have left over here. There's a lot of stuff I was going to go into. I just want to point out quickly at the Metropolitan Museum, there's going to be a beautiful exhibit of the works of Raphael at the Met going through June 28th. And then they have an upcoming major costume art exhibit that's going to start May 10th, again, also at the Metropolitan. If you didn't make it to the annual Orchid Show at the New York Botanic Gardens, that's still on through April 26th. This is springtime, and I just got this email from Longwood Gardens. The tulips are at their peak. So you could go to their website and find out a little bit about it. It's in Kennett Square, Pennsylvania. The driving time from my house to cover the 97 miles is about a 2-hour ride. But if you're interested, you got 12 and a half minutes, you can see my video that I made a few years ago about Longwood Gardens at tulip time. And if you're interested, you can see that in 2D, or you can also see it in 3D. And there's a way to go and select which viewing mode you're interested in. It's 9:02. I'm actually set up to stay online with you till 9:30. I'm just curious, how many of you would want to take 12 and a half minutes for Longwood Gardens at tulip time? It's really nice. Doesn't make a difference to me. But let me hear some yeses of interest.
Yeah.
Yes.
So I'm
Yeah,
leaving.
I would be
Yes.
interested.
Yeah,
Yeah.
okay. Then I'm going to take you there.
By
But
the
before
way, Bill,
yeah,
did you know that today is National Orchid Day?
I did not know that, but it's
It
good to
is.
know. We're gonna one of these days get back to Affinity. I just got a notice today that their newest update is now out, and you can get it for free. Again, all this I'll put into the after meeting notes. This Affinity replaces Corel Photo Paint, Corel Draw, Photoshop Illustrator, Photoshop uh, InDesign, all kinds of stuff, and you get it all for free. And it seems to be getting better and better. Next month, coming attractions, there's this new program called Vibe Voice, and John Stempel and Dom Corbo are going to let us know how to use the software. And I think, Dom, am I right? That's what you used at the beginning when I did my little introduction?
Would you call it again?
Vibe Voice?
Never heard of that.
I'll have to be back in touch with you. And Alan Kasov's going to tell us, how to tell if a photo, or video, or sound is AI generated. So that's coming attractions. Do, 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 do. Boom. Okay, now I'm going to take you to YouTube.
Hey, Bill, I have to check out.
Okay, well, the connection will be there if you're interested. It's
Tiptoe to the window, by the window, that is where I'll be. Come tiptoe through the tulips with me. Tiptoe from your pillow to the shadow of the willow tree, and tiptoe through the tulips with me. Knee deep in flowers will stray with you.
I don't know what's going on here, folks. The sound is a little screwed up.
I kiss you in the garden, in the moonlight, will you pardon? Come tiptoe through the tulips with.
I think one of our co-hosts, or maybe another co-host, maybe is interfering with what's going on. Anyway, I'll send you the link. I think you'll enjoy seeing the whole thing. And I'm going to sign off. I don't know why this doesn't want to stop. Let's see what's going on.
It's crazy, April showers.
Oh, there we go.
I kiss you in the garden, in the moonlight, will you come tiptoe through the tulips with me? Tiptoe, come on, tiptoe with me.
I sent you guys the slides.
I don't know what's going on, but something's screwed up. Again, I'll send you the link. Larry, you sent me the link for the slides, right?
I sent you and John the slides, the file.
Okay. Good night, everybody. Enjoy the spring.
Good
Good
night. all.
night.
Take
Thank
care,
you.
guys.
Thank
Okay.
you, Larry and Bill and John. Thank you. Take
Oh,
care.
Pam, do me a favor. You have my
Yes.
email address. Send me your correct email address.
Yes, I'm not sure if I do have your email.
Well, here it is. Write down, okay?
Okay.
WM, as in William,
Uh-huh.
WM, the letters AG,
Uh-huh.
as in the chemical symbol for silver on the periodic table,
Uh-huh.
AGMAN, man. So that spells my name, William Silverman, at
Okay.
opt
Uh-huh.
online.net.
Opt
OPT is
online.
Oscar Peter Thomas, online.net.
So WMAGMAN at optonline.net.
You got it.
Great.
Thank you.
Thank you so much, honey.
Okay,
Thank you.
and Richard
meeting.
Bradford from Australia. Hi there, Richard. I heard that in Melbourne, I think it was Melbourne, when we had that really cold weather here, you guys reached 50 degrees, but that was centigrade, was 122 Fahrenheit. Is that right, Richard?
That does happen.
That's insane. And who says there's no such thing as global warming in spite of all the cold weather? Today, I don't know, here in New Jersey, we came pretty close to 90 degrees, I think. Anyway,
Yeah.
Goodbye, everybody.
Good night. Great meeting. Thank you.
Thank you.
Bye.
Thanks for coming. See you next month.
Bye.